Hello dear students, welcome to Pen and Paper Chemistry. Today we are going to discuss the answers to the questions on bond line notation on the IUPAC nomenclature worksheet that I had posted on the channel. So are you ready with your pen, notebook, and if you have attempted these questions earlier, of course with your answers. These are the questions specifically posted on bond line notation, and I had given you a hint as well. In case you have not been able to attempt or you've not seen this worksheet earlier, please go ahead and try these questions before you go on to see the solutions on it. Let's get started with the first structure, that is hex 3-ine. So in other words, my compound has 6 carbon atoms. 1, 2, 3, 4, 5 and 6. Yes, this is what I am representing right now is the structural formula. This is not the bond line notation. We are coming to the bond line notation. We will decipher it from here. So now at the third position I've got triple bonds. So 1, 2, 3. So here there's a triple bond. Of course the rest are hydrogen. Now how do I represent it by the bond line notation? As the name indicates, bond line notation. That means this type of representation tries to concentrate more on the bonds between the atoms rather than the actual number of atoms which are present in the compound. Unlike the Lewis structure or the structural formula or the condensed formula where our focus, we also take care of the hydrogen, bond line notation tries to depict the bonds. So let's depict the bonds between the carbon atoms in hex 3-ine. So I have got 6 carbon atoms over here. I will represent the bond between carbon number 1 and 2 by a straight line. This is here, right? So understand here that this is 1 and this is 2, correct? Then 3, 4, 5 and 6. So as soon as you draw a line, this is representing 2 carbon atoms of the chain. You have to remember that this is not 1, this is 2. So every time you draw a line, you say 2, 3, 4, 5 and there we go 6. Right? Okay. Now, how do I go on to show the triple bond? That means carbon number between carbon number 3 and 4, there's a triple bond. Now, if you notice or if you remember and recall, triple bond means there are 2 pi bonds, and 2 pi bonds means this is a linear molecule. Whereas the representation that I have used over here does not indicate a linear molecule. So how do I depict it correctly? In other words, my carbon number 3 and 4 have a triple bond between them, right? So this is my carbon number 3 and 4, and further on they are connected by single bonds. Now as we said earlier, bond line notation means we are not going to show the atoms. So what do I do in order to depict it? So let me join this line by a single straight line, wherein what the ends of these triple bonds depict a set of carbon atoms, carbon number 3 and 4. Let's put it more clearly. So I've got triple bond wherein this is 1 carbon atom, here's second carbon atom, here's the third carbon atom, here's the fourth carbon atom, and we have to depict the 5th and the 6th carbon atom, right? Please remember, in order to show the triple bond, here the ends of the triple bond are representing two carbon atoms over here, right? This does not mean a shortened triple bond. This is how we will represent a triple bond when representing it by bond line notation method. And what about the ends? So each of your vertices here is representing a carbon atom, as well as at the end, if there are no double or triple bonds, these ends indicate the presence of a methyl group, which we do not show in the bond line notation method. It is understood that your terminal groups contain carbon unless otherwise depicted. Let's suppose you have the OH group or Br or Cl, then only it would mean differently, otherwise it represents a carbon. So supposing I have to number this, then this is carbon number 1, 2, 3, 4, 5 and 6. Got it? Now go ahead and try 5,6-diethyl 3-methyl dec4-ene. Now in this, come to the word root as was our focus during the writing of the structural formula. Dec4-ene, that means my main chain has 10 carbon atoms. So we start 2, 3, 4, 5, 6, 7, 8, 9 and 10. Just to be doubly sure, let's number them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now we need to, on position number 5 and 6, we have diethyl. So ethyl is CH2CH3. That means there are 2 carbon atoms. So I draw a line and I depict it like this. I draw a line and I depict at this. Meaning to say, here there's a CH2 and here there is a CH3. But since this is bond line notation, we do not write them, we only depict it by the bonds. And what do we have at the third position? We have a methyl group at the third position. So we'll simply again draw a line. Please notice I am not joining them. So we have here 5,6-diethyl 3-methyl dec4-ene. Since it is not specified, oh, by the way, we forgot the ene, the double bond at the fourth position. So that means we have a double bond between the fourth and the fifth carbon atom. This completes the structure of 5,6-diethyl 3-methyl dec4-ene. You notice over here, we've not represented any of the atoms, right? This was CH2CH3. Simple. Got it? Okay. Let's continue with structure number 3, methyl propanoid. So prop means how many carbon atoms. So I've got 3 here, 2 and 3. There we go. Methyl propanoid. Now propanoid means C double bond O CH3. In other words, oxygen is a part of my chain. At this carbon, I have got a double bond O, and there is a CH3 group, right? Now try and imagine the molecule over here. So what you've got is, just to visualize the structural formula, you've got a CH3 here, you've got a CH2 here, you've got a C over here, and you've got a CH3. Write it in the condensed form, CH3, CH2, COO, CH3. So 1, 2 and 3. Methyl over here, it's an ester, so methyl propanoate, and this completes the structure. So how do we show the bond line notation? Only the bonds to be depicted here, not the atoms, please. And this completes your structure of methyl propanoate. Right? Would you like to try the next one yourself before I go on to explain? Please pause the video, give it a try. It's 3-ethyl, 4-methyl, penta null. Remember, the line that you draw, the first line that you draw covers 2 carbon atoms, right? 2 carbon atoms of the chain. So in this structure, how many carbon atoms are there? Look at the word root. Go ahead. It's a penta null. So we have over here 2, 3, 4 and 5. Now for the sake of clarity, I will have 1, 2, 3, 4 and 5. 3-ethyl. So what we'll have here? Go ahead. 4-methyl. That means at the 4th carbon atom, I have a methyl. So that means how many corners will be there? None. It's a straight line, right? And then we have to represent the ul. Ul means what functional group is it? Yes, it's the aldehydic group. So how do I represent the aldehydic group? Aldehydic group is CHO. I already have a carbon at the end, so we have a double bond O and an H represented here in order to show the ul group CHO. Got it? Good going so far? By the way, if you've drawn your structure like 2, 3, 4, 5 and a double bond O and an H in order to represent the penta null, then remember to count it from the right hand side. So 1, 2, 3, 4 and 5, and then we have 3-ethyl. So at the 3rd position you've got the ethyl group, and at the 4th position you have the methyl group, right? So then your structure is going to be like this. So just be careful if you mirror it, which side is position number 1. You have to be careful about the rules of the nomenclature. Next one. Now just now we did the bond line notation for an ester. We did methyl propanoate. Here you've got butanoate. So would you like to give it a try yourself? Only thing is there's an additional alkyl group. So let me see where you write the CH3 and how do you represent the C2H5. Butanoate. Draw the structure, then tally it with the answer. So butanoate, 2, 3, 4. Got it? Now at the 2nd position I have ethyl. There we go. And at the 1st position I have the ester. How do we represent an ester? It's COO and it's methyl ester. So C double bond O CH3, right? Just expand it and you will have the answer with you. So this carbon here is my carbon, the 1st carbon atom in the molecule. So we are not going to write that carbon. What do we have is we've got a double bond O attached to that carbon. That carbon in turn is attached to an oxygen, and that oxygen has a methyl group attached to it. Got it? This is how we represent methyl 2-ethyl, methyl 2-ethyl butanoate. Our methyl, the place where the students get confused, the methyl that starts the name is actually the part of the ester group, and the ethyl, which I'm writing it as a substituent, is part of the side chain. So just be careful about that. Got it? Now I think you'd be able to nail bond line notation very easily. You've got 2-bromo, 5-methyl hexanoic acid. So hexanoic acid means my structure will have how many bonds? Go ahead. So 2, 3, 4, 5 and 6, right? I'm going to number it from the left hand side or the right hand side. Right hand side, if you are comfortable, you can do that as well. So let me do this as C double bond O and OH, right? So this becomes my position number 1, 2, 3, 4, 5 and 6. At the second position, I have a bromine. So 2-bromo, 5-methyl. That means at the fifth position, I have a methyl group. How do I represent? Yes, simply by a straight line. Got it right? You could do both ways. You could take numbering from 1, 2, 3, starting from the left hand side. In that case, your C double bond OOH group will come to the left hand side and the bromo will go to the right. The methyl will go to the right hand side. So accordingly, you will have to number very, very carefully. Enjoying it now? It becomes pretty easy, right? Okay, now the next ones are cyclo compounds. Would you like to try them yourself? We've already spoken about the primary prefixes cyclo. Both of these are having the term cyclopentanol and cyclobutane. So cyclo means I will have a ring structure. My word root is cyclopentan. That means I have a ring with 5 carbon atoms. That's a nice pretty hut that we've got, right? Then we've got at position number 1, we've got all. So let's say this is our position number 1 and I have got an OH over here. Then we've got 3-methyl. That means at the third position. So if I'm starting from here, position number 1, 2 and 3. So I have to represent the methyl, which will come as a small tail at the end. Easy, right? Go ahead, try the next one yourself, where we have to represent 1-bromo, 2-chlorocyclobutane. Oh, that's quite a lot of it. So butane, how many carbon atoms in the ring? Correct. But means 4. Cyclobutane, that means 4 carbon atoms in the ring, 1-bromo. So we will have at the first position bromine. At the second position, it's the chlorine, following the alphabetical order of numbering as well as naming. Hope your fundamentals in bond line notation are clearer now and you are in a position to try a few more questions which I will be posting very soon. Let me know your feedback on this set of videos and how far they were helpful. And most importantly, how many smileys did you collect while attempting the questions on this IUPAC nomenclature, and how many smileys did you share with your friends and classmates? Connect with you soon with another set of new videos. Stay safe, stay happy and stay healthy.